Welcome to the Technology Slam that's a part of the 5th Wood Heater Design Challenge. Here we are today with 9 teams vying for a prize pool of $120,000. I just want to sincerely thank my colleagues at Brookhaven, Rebecca Trojanowski, Tom Butcher, my colleague VRAP at Berkeley Lab, John Ackerley at Alliance for Green Heat, who is a staunch advocate for this industry and a great partner with DOE.
So today we have the 9 best teams and we're all excited to hear their pitch. Based on today's presentations, the judges will award each team points in 4 categories to determine the top 3 teams that will win $15,000 to help advance their design and travel to Brookhaven for R&D testing in spring of 2023.
Good morning, everyone. Okay, so we don't have much time to spare, so let's get moving. We'll go to the first pitch, which is Davidoff.
Davidoff Industries has been established since 1987 with 35 years of experience and one of the most trusted heating solutions representatives from Canada through the Americas. With the partnership of Otter Controls, Davidoff Industries, and the expertise and mind of Mr. Glenn Hughes, we have developed the Otter, the first ever purely mechanical working wood fire stove control.
The core innovation we are showcasing today is the Otter Combustion Control, which automatically regulates the stove's primary air supply. The probe is inserted directly into the flue, measuring the temperature of the smoke particles and gases at their hottest point. As the outer housing of the probe expands and contracts, the non-expanding rod within regulates the air valve to suit. Smoke emissions in this real-life reflecting test cycle fell from 143 milligrams by meters cubed to 39 milligrams by meters cubed. The average CO reduced from 0.21% to 0.09% and was consistently very low with the automatic stove. Efficiency with the thermostat rose from 73.9% to 83.1%. Thank you for your time and consideration, everyone. Thank you.
So we're going over to Kleis Engineering now.
I've heated with wood almost my entire life. Having an understanding of combustion and thermodynamics, I sought to apply the same science to the challenge of designing a clean burning and efficient wood stove. It's taken over 10 years, but an elegant and capable control algorithm has resulted. The OmniBurn burns smoke-free and efficiently while burning woods that are up to 50% moisture and even semi-rotted. I estimate it can be produced in quantity for less than $600 cost. Here's the e-stop valve. When power is interrupted, as you'll see, boom, intake is totally closed, stove is shut off. And that's it.
Thank you very much. Well on time. MF Fire is the next one.
So I'm going to introduce you to ACE. ACE is an automated single burn rate catalytic wood stove. It monitors the temperature and uses that to drive automation. We use a smart controller connected to an actuator to automatically open and close the bypass at just the right time, thereby maximizing the benefits of lowering emissions and increasing efficiency. The impact is that we are looking to lower real-world emissions by 30% and increase efficiency to over 80%. We're at an early prototyping phase, and we're currently evaluating actuator options.
So the next pitch up is Wittus.
So our team, headed up by Ingo in Germany, has designed a multi-fuel add-on heater. But this will allow the user to burn either wood pellets or wood chips in this particular host stove, the shaker stove.
So it's an engine combustion chamber below the ashtray. The fuel supply is from the back and the primary air from the side. So to sum up, we have a multi-fuel burner for pellets, wood chips, and cordwood. Very low emission rates, below 0.15 grams per hour for pellets and wood chips, and for cordwood below 0.8 gram per hour. Again, without ESP. With ESP, it's 50% lower or even much lower.
Okay, thank you. Let's move on to the next pitch, which is Stony Brook University.
Hello, everyone. So we are from Stony Brook University, and we'll be talking today about our concept, the automated intelligently modulating stove.
Obviously, wood stoves have tendency to produce emissions, right, as a result of either poor mixing low chamber temperatures, low residence time, or just insufficient oxygen in general. So our proposed solution is to vary the combustion air. Or by automating the process, we can make every user an expert.
Cost is less than 10% of a typical cordwood stove, and the potential is we can finally tackle that times 100 emission excursion that is occurring during startup or smoldering phases.
Thank you very much.
Thanks.
Let's move on to our sixth pitch.
Hello, everyone. Yes, it's Aprovecho. Thank you.
For this project, we spent over 300 hours to evaluate 9 configurations at 3 power levels for over 50 tests with real-time and gravimetric emissions monitoring to optimize performance in an existing pellet stove manufactured by our partners at US Stove Company.
The result of this extensive development process is a novel patent-pending burn pot configuration with independent control of high momentum jets of primary and secondary air.
We're excited because you can see that these innovations were able to dramatically improve performance over the full test cycles.
We look forward to applying this innovative approach to this and many other pellet and cordwood stoves to help make biomass a clean and sustainable local fuel that protects health and climate.
Thanks very much. That's all that we have time for, unfortunately. We need to move on to the next pitch, which is wood gas pyrolytics.
All right, fab stove wood heaters. Top lit updraft TLUD microgasification creates a pyrolytic front that migrates downward, sustained by a controlled upward flow of primary air. The emissions are similar to those of LPG, natural gas, and biogas. This gas burning stove makes its own gases from solid fuel. We identify at least 6 markets for larger units. America needs carbon negative heating as soon as possible. We invite you to please join us to make this happen. Thank you.
Thank you.
Thank
Okay,
you.
let's move on quickly to the next pitch. We have Chimney Cherry now.
Chimney Cherry is a retrofit device which is scaled down from a tried and true industrial technology for an ideal wood burning experience. So there are 3 unique aspects of a product which I'd like to highlight. The first one is the collection of particulate matter. Now that brings me to the second aspect of a technology, which is self-cleaning. The third is our installation, and this is probably the most unique I think we have.
And our business model is threefold. First, selling through local wood burning stove vendors. Second is a buy now, pay later financing model to accommodate low income wood burners. And finally, we plan to collaborate with chimney manufacturers like ICC Excel in order to create product licensing partnerships. Our device is able to reduce 90% of up to 90% of particulate matter, self-cleans, and is easy to install, making it the ideal product for people on the market. Thank you.
Great. Let's move on to the next team, the last team, Stanford University.
I'm pleased to introduce you to the concept of the Stanford smokeless stove. So how to make a smokeless fuel-efficient wood stove. Our proposal is to reverse engineer a polar bear. We use countercurrent heat exchange of the waste heat in the exhaust stream to create a hot chamber. Organic particles passing through that chamber are combusted. This afterburner harvests the energy from the particulates and leaves the exhaust smoke-free. The opportunities for business expansion for the afterburner are also large. It could be incorporated into any stove design, higher end stoves, for example, but also the afterburner technology could be used to solve problems in other areas.
Thank you very much. I want to thank all of our teams for fantastic presentations. I've certainly learned a lot. Good luck to everybody. I'm going to hand it over to Tom.
You know, these folks put a lot of work into the preparation for this. It's really clear. They worked hard to get it down to the time constraint that we provided to them, and you know, yet answer the most important questions, and we appreciate that. So thank you to all of the participants again.